Okay, so today what we're going to do is we're going to look at another way in which you can get probabilities. And so we're going to be talking about what are called probability trees. Probability trees are ways of organizing topics when you have more than one probability or more than one event happening. Sorry about that. More than one event happening. Remember, an event is just one experiment, like so you roll a die, that is one event. And each event gets its own probability. And so we're going to look at how those probabilities connect and how we can organize that in a kind of a scheme, a little drawing. Okay? So keep the idea of trees because we're going to be talking a lot about branching and branches. All right? So the first thing we want to do is talk a little bit about how to organize the probability tree. And most people don't organize them clearly enough. They don't draw them neatly enough, and they don't leave enough space to draw an effective probability tree. So leave yourself enough room. You're going to see that on many of the problems, at least in the very beginning, they're going to have the tree drawn, and you're just going to need to fill in pieces of it. And then later, you're going to have to be drawing your own trees. Okay? These can be a little tedious. I'll grant you that. But you need to complete all the work all the way. Otherwise, you're going to get yourself into trouble when you start answering the questions. Once you've built the tree and done the math, most of the time it's simply a matter of reading from the tree. Okay? So, let's talk first about two things that we reviewed way back when we first started this section. And that's when you have probabilities that involve the word and. And I want you to keep in mind that all of the branches, if you're following a branch, that's an and statement. It's this, then, and this, and this, and this, etc., depending on how many branches you have. Remember that when you have the word and, what you're always going to be doing is multiply the probabilities for each event. But for the word or, that's when you have different things happening. You get different probabilities and you need to combine them in the end. Remember, that always means add the probabilities. And we'll look at examples of each of those so you know exactly when you're supposed to be doing which one. Okay? It's pretty obvious, pretty clear. All right, so let's look at how to build a probability tree. I do it slightly differently than the book, but only with one word. Okay, so it's not that big of a deal. What I always do is, the first place, I always put the word start. And the reason for that is that it really gives you the idea of where am I beginning? What's the beginning point of my experiment? And am I starting from the beginning? Now, you're not going to understand that question until later. It's something that came up not in a homework question, but on one of the NCEA exams. So I want you to. So I'll talk to you about that. So always think about where you're starting. Are you actually starting at the beginning, which is 99.9% of the time? But you can have something already happen and then be building on that thing happening. Okay. So think about where you start. From the start, what's going to happen is each possibility gets a branch. Okay? Now, we're going to just keep it easy here and think about something very easy. Let's say you were playing a game of netball, for example. In a game of netball, you can either win or you can what? Anybody?
Lose.
There you go. You can either win or lose, right. Now, do some teams win more often than they lose?
Yeah.
Yep. And the other way around, yeah? That makes perfect sense, doesn't it? So the probabilities of winning or losing change depending on who you're talking about winning or losing. Some teams are more likely to win than others. Okay? So those probabilities are rarely almost never the same, right? Either they're more likely to win or more likely to lose. So keep that in mind as you go as well. Okay, each possibility gets a branch, okay? And they must add to 1. Now that goes back to something else that we talked about in the beginning when we reviewed probability. It's always a number between 1 and 0, with 1 meaning a certain event. Well, if you play a game where the only possibilities are win and lose, you either get to win or you lose. So those two things added together have to add up to 1. Otherwise, you're missing some of the probability in there. Okay? Now, we can use that fact to be able to find missing numbers. So if I know the probability that someone wins is 70%, but I don't know what the probability is for them to lose, then we simply subtract 70% from 1 and get 30%, right, to get the probability that they'll lose. Now we're going to be doing math with these, so we wouldn't want to usually use percents. We'd usually change them to decimals. Okay? All right. Third, label your events. So in other words, for example, we could have the first game, second game, third game. And I'll show you where these labels go when we actually draw it. But right now I'm trying to just bring your attention to some of the key pieces. A lot of times I don't see this, and then it's really easy for students to get confused about what they're discussing and what they're dealing with. Okay? So make sure you label them. Step 4. Put the probabilities on each branch. Put in the numbers. Okay? Now, when you're putting in those numbers, make sure you remember that they have to all add to 1. Keep that in mind as you go. So if you know one probability but don't know the other, you can find it by simply subtracting the one you know from 1. Okay? Always add them together. It's one of the most common mistakes is getting the wrong number in the wrong spot, and it's going to throw every answer off. Okay? If you want to get an achieved, you will draw these properly with the right numbers on them, or else everything else is gone. Okay? So be really careful. It's easy. Step 5. This is another thing that students just do not want to do. Students just do not want to do because it takes some time. Hold on a moment. I got to figure out what I just did. There we go. Sorry, I hit a button. All right. So, what you need to do at the end is list the outcomes at the end of each branch. Okay? So in other words, each branch is going to have some certain set of outcomes. Win, lose, win. Lose, lose, win. Something like that. And it's going to be listed as a probability. So we want to write it as a probability statement. So write it as a probability statement. Remember, that's where you have the probability of something equals. Okay? Now, 6. Calculate probability for each branch. And again, if you're following the branches, all you're going to do is follow the branches. And if you're following a branch, that's always an and statement. I lost and won and won. So those are and statements, so that always means to multiply. the probabilities just along the branch. Colored pencils, highlighters, just circling something, but indicate how the branches go. But you want to do something that that makes it easy for you to then do another branch, okay? So don't get too carried away when you're coloring these. I'll show you what I mean. Now, next thing. Every probability at the end should also add to 1. So in other words, at the end of all the branches, once you've done all those probabilities, as long as you have the same number of branches all the way, and you'll see an example of what I'm talking about there. Okay, then they should add to 1. All right, and finally, if you have more than one probability, in other words, you have an or statement, this branch or this branch, that always means to add. Okay, now that's a lot of stuff going on, but these are really fairly simple. It's a lot harder to describe and to begin than it is for you to work these. So once you start getting these, the hardest part of the question is, the hardest part of these is finding out what question they're asking, knowing what it is they want you to answer, not drawing the tree. Drawing the tree is the easiest part. Now we need to talk about one other thing before we move on that wasn't in our review of probability, but we need to talk about it. And I kind of hit on it. Not every tree will have equal branching. In other words, some branches may stop before others. And we're going to look at a specific example where that happens today so you can see what I mean. It's very straightforward. It makes perfect logical sense that they stop. Okay? But you've got to be aware of that before you start, because if you don't know that, then you may think, I got to get all of these branches to match, and that's not the way it works. Okay? And that brings up something a little different called conditional probability, which was not in our review, but for some reason they throw it in here. Okay? So we need to talk about it. Conditional probability is the probability of one event given that another event has already occurred. Here is a classic example, one that you will all understand. One event. Ooh, that's not right. One event. It's not one word. The probability of one event given that another event has already occurred. Classic conditional probability. If you clean your room, then you can go to the mall. Right? One thing is not happening without the other. If you do your homework, you will do well on the test. Okay? So you see that there's a condition that has to be met before the other condition can occur. And to get conditional probability, we have to do a little more math than we do for just a straight probability. And it also has a little funny notation. It's written as the probability of A, thin a line B. This is read as the probability of A given the probability of B. Okay? So, even has a special notation. Now, you don't have to use the special notation. You can just write it out in words, which is what I'm going to recommend. Okay? Writing things out in words, it usually has more meaning for us, and it also has more meaning in your answer. And you know that in CEA, you want to get as much meaning in your answer as you can possibly get. But there's a formula for it. It's not difficult, and it makes perfect sense. You're going to find the probability of A and B. All right? So the probability of both of them. But then you're going to divide away the probability of A happening all by itself. And again, you're going to see an example of this, and it's pretty straightforward, but it's not straightforward if they just throw at you in the dark, which is what they do. So we'll talk about it, okay? But again, remember, this is a special case. The conditional probability means there's a condition. So what is the probability of winning 3 games? That's just straight probability. What is the possibility of this particular team winning exactly 3 games? That one is conditional, right? So we'll look at examples of those as we go. Okay. Are we ready? So let's just go to the book, and I'll show you what these look like. So go way there. So probability trees. So they just jump in by giving you an example. So there's a special teams award presented at a school assembly, and the hockey team has been chosen to receive the award. The award must be accepted by either the captain, or if he's absent, then the vice captain, he or she, sorry. The captain of the hockey team is present at the assembly 95% of the time. 95%, we know that means a probability, right? The vice captain is present in the assembly 93% of the time that the captain is present, and 75% of the time if the captain is absent. So notice that the vice captain has 2 different probabilities, right? Depending on what has happened before. Calculate the probability that both the captain and vice captain are present in the assembly, and then calculate the probability that the award will be presented in this assembly. Because if neither one of them shows up, they can't give the award, right? Okay. Decide what the events are, first of all, and their order. So always think about what it is you're measuring. So here, if you look at this, event 1 is that the captain is present, or he's absent, right? You have 2 possibilities. He's either present or absent. The second event is talking about the vice captain, and he can either be present or absent, right? And he gets even more branches because the captain only gets present or absent, but the vice captain can either be present or absent depending on branching off of whether the captain was present or absent. So do you see how each event gets a new branch? Okay. So in the end, I end up with 4 branches, right? Okay. Now we're going to put probabilities in the middle of each one of these branches so that we know what the probability of that event happening is. Okay. Now, but before we do that, well, let's see. We might go ahead and do that. Now, let me see if I can scroll up a little bit. Yeah, they redo it anyway, so okay. So we're going to add the probabilities for each event to the middle of each branch. So adding it means they mean writing it in, not add like the addition. So remember it said that he's present 95% of the time, so 0.95, which means that he's absent 0.05% of the time. Remember that these 2 numbers have to add, sometimes, to equal 1. 0.95. So we knew one, so we could get the other by subtracting it from the number one, right? Now, the vice captain is present or absent depends on whether the captain was present. It said if the captain was present, which is this branch, right? So here's present. If he was president, then the vice captain is present 93% of the time, so 0.93. Subtracting that from 1 gives you the other one. And again, remember, these two have to add to equal 1. Always check that. Be very careful. If the captain is absent, then the vice captain is absent 0.75% of the time, which means, present 0.75, which means he's absent 0.25. Again, these have to add to make a 1. Okay? Be very careful. If they give you a chart, do not just assume that all of those numbers are correct. Okay? Watch out. All right. Okay? So that's how we get the numbers and the probabilities in there, and they all need to add. Okay? Check that the probabilities for each branch add to 1, and then at the end, list all of the outcomes for each branch and calculate the probabilities at the end. You multiply along the branch, right? Because it's an and statement. So here's what I mean by the probabilities at the end. Now, they're going to use some notation. So remember that if you have V with an apostrophe, that means not, right? So that's V prime is how it's read, and this was in our review, and that means not something. So V means it has happened. V apostrophe means it didn't happen. Okay? And those two things have to add together to make 1 as well. So be careful about your probabilities. All right? Now, let's look at this one, because this one is completely filled out for you. So they have the probabilities for each branch, right? And what they've done is they've followed each branch and first wrote they've first written the probability statement. This one is the first branch. If you follow here and here, the captain was present and the vice captain was present. So that's the probability CV. And you can abbreviate any way you want to. They did captain and vice, and because you don't see the apostrophe, you know that means that they were both present. They both happened. And notice what they did was they took the two probabilities, the 0.95 and the 0.93, and multiplied them together to get the probability for that particular statement. So if you follow those along and multiply them all out, that's what you get on that branch. Now, again, it's a lot to write, but it is critical that you do this for every single branch. So the next branch would be captain present, and vice captain absent, right? We've already done that one. So that's here. There's the probability statement for it. Probability, captain is there, vice captain is not. That's not, that little apostrophe means not. So they took the two probabilities along the branch, multiplied them together to give the probability for that whole thing. Okay? And they just followed it all along each branch. We did there and there. We got this information, right? C apostrophe V, because he was absent, he was present. Okay. Then finally they did the last branch, which is here and here. That's when they were both absent or both nots. They multiplied them together. Notice then they drew a line and they took all of these probabilities and they have to add up to 1. And that's because we had an equal number of branches. This branched once and then branched again. So you see that all the branches are the same length. That means this will always add to 1. In some cases, they may not all be the same length, in which case it won't add up to 1. Okay? Looking okay? Your graphics calculator is going to be your friend here because it will show you, it'll hold what you're multiplying together. So be careful when you're multiplying all these little percentages together that you look at your numbers on your screen to make sure that you've entered the correct thing. The multiplication is easy. Also, this is a place where we're going to really get a lot of practice writing these probability statements, which is one reason why I focused on the math last time and not so much how things are written, because I knew that you were going to get lots of practice writing these probability statements as we go, okay? And answering the questions. I like to do it when in times when the math is a little easier. Okay. So, then when you have that, you can check that they all add to 1, highlight the events that are required along with their probabilities, and add these to the overall probability required. So, in other words, as you're answering your questions, then highlight or circle or whatever. But be careful because you'll be using the same probability tree to answer lots of questions. So if you highlight it in highlighter, and then you can't undo that very easily. So be careful. I like to circle it in pencil or something that I can erase, or just do a little check mark on the ones that do work. That's perfectly easy because then you can get rid of it, right? So let's look at it. So we want the probability that the captain and vice captain are present. So we had questions. So the probability the captain and vice captain are both there. Now you can write that out in words just as easily if you want to. But make sure that whatever probability statements you use here, you reflect here, so that when someone else looking at it will be able to look at your answers and understand them. Because if we can't, then you're not going to get it right even if your numbers are right. Okay? If your probability statement is not correct, then your answer is not correct. Okay? So, let's just go back to the tree and find every place here where this happens. Well, if you look at it, here, probabilities of C and V, so that one will work. This one has a V prime, so that one won't. This one has C prime, and this one has C prime V prime. So the only branch where they're both there is this branch, and that probability is already calculated out for us as 0.8835. Remember, we typically use 4 decimal points for probability. Okay? So once you've built the chart, built the tree, and found out what each branch has, then it's pretty easy to answer the questions. Okay? Let's look at the next question. Probability that one or both of them is present. Okay? So, it doesn't matter which one. Okay? So we just have the probability that one or both. Now, this is not a conditional probability. It's just an or statement. We can accept that one of them is there or both of them are there. Okay? Well, here both of them are there, so that's good. Here one of them, the captain is there, that's good. Here the vice captain is there, so that's good. But here, C prime, V prime means that neither one of them are here, so that one's not a good branch. So we have 3 branches that would satisfy that condition. So we're just going to take all of those probabilities along the branches and add them together. Oops. Now, add them all together. Or, we know that the total is 1. I could have subtracted out the one that didn't work and it would give me the same total. Now, I'm not adding all those together, guys, because they've already done it here. You get 0.9875. So about 98.75% of the time, because many times they're going to ask you then to answer your question as a percentage. They don't here, but if you did, remember you can just move the decimal 2 places. And 98.75% is a pretty big percent. So you can pretty much count on the fact that one or both of them will be present at the assembly. Now, if I wanted to find out when they're not there, I could just subtract that from 1, but I also know that this is the branch for when they're not there. So I know that probability. And that's a very, very tiny number. As a matter of fact, if you convert it to percent, it would be 1.25%, which is a very small percent. Okay? So, how does that look to you guys? You want to see another one? All right. Well, we're 30 minutes in, so what I'm going to do is, I don't want these to take too long. So what I'm going to do is I'm going to break the assignment into a couple of pieces so that you don't have to get too much at one time. I really want you to concentrate on them. So look at this one, for example. We're just going to go really quickly into building the tree. And I'm not even going to finish all of those probabilities because they've started for you. But we'll just do the first ones, and they should be fairly straightforward. Okay? So you have the probability that someone is either a boy or a girl, right? And they said this is 0.55. So to get this one, we simply subtract that from 1 and get 0.45. Okay? The probability that a boy passes is this, which means that if he fails, that's 4/10, right? The probability that a girl passes is this, which means that the probability that she fails is that. Okay? So you see that it's easy if you remember that they have to add up to 1. Just subtract it from 1 and you know the other one. And most of these are fairly easy numbers you could do in your head. Okay? Then, notice that they just followed the branches. Boy, pass. That's the probability. Boy, pass. Right? And it's because we have the words here, we can just use the initials in there because it all goes together. Right? You wouldn't have one thing without the other. And so they just took the probability here, multiply them together, and give you the probability of the whole thing. Okay? And here they're just asking you some different questions. Probability the paper belongs to a girl who fails. Okay? That means we need girl, fail. Right? And again, you'll already have all the numbers worked out. All the math will be done for each branch here. Right? So you already have it all figured, filled out. Probability the paper belongs to a girl who fails. Okay. Probability the paper belongs to a boy. Now, remember, if it belongs to a boy, that's any of these. So it doesn't matter about pass or fail. So it's this one or this one, as long as it has boy in it, right? Then we're good. And, of course, since that's 2 branches, what we'll do is take those and add them together. It's very common that you're going to be adding branches together. Probability the student belongs to student who failed. All right. So you're looking for fail. There's a fail. There's a fail. Find the two probabilities will be listed, and you're just going to add them together. Okay. Very straightforward once you've drawn your tree. Now, F. If 1,600 sat the test, how many failed? You're going to use the probability from A. Remember that this is something we also reviewed, and we used it also in the other one. It's something called expected number. And that is simply the probability of the event times the number of items or number of people, in this case, 1,600. And make sure that when you're answering this, you use your units. These are 1,600 students, not just a number. Okay? Then they just give you another calculated probability. And since we said or, we know we're just adding them together. Okay? So what I'm going to do is I'm going to give you the first part of this as the assignment, and then we'll move forward from there. Okay? So we'll take 2 class periods to work on these. That means I need for you definitely to get these done before we meet again. Okay? So set aside some time. Use the rest of the class time for sure to at least start so that you'll know if you need to contact me immediately. But otherwise, you do the rest of it for homework. Okay? So for these. Let's see, you could do that one. That one's quite, yeah, that one. This one is ugly, but very doable. Okay, let's see, how many are there? So then they get into ones where they don't help you build the tree. So you should be able to do anything from 1 through 7. So let's just say that our homework, we'll do 1 through 7. Again, there's a lot of little things in there, but get them done before we meet again because you need to be able to then build. We'll talk about building your own tree and some things that could happen. Watch out for that conditional probability. As a matter of fact, you're going to see it right here. It's possible to see it here because notice that these branches don't go. This one stops there, and these others keep going. Okay, so be careful about that if they keep going, and see what happens to the branches. Contact me if you have any questions. Happy to help in any way I can.